Okay, here we are, our fifth question. Simplify the function and state the d and r. All right, so here's our function. 4 of x, or f of x, my bad, is equal to x to the 4th power divided by the square root of x. All right. Now, I don't like when we're dealing with different symbols like this. So like I said with our last problem, this exponent can, this radical sign can be read as x to the power of 1/2. So this is just x to the 4th divided by x to the 1/2. Cool. Very nice. So what does this do? Recall that when we have exponents that are being divided, we can subtract them. So if we have a to the x, or a cubed divided by a squared, well, that's just a times a times a over a times a. These a's are going to cancel and you are only left with a. So this is just a cubed minus 2. So we are going to subtract our exponents here and as well. Yeah, because this, since it's under, is our denominator. Another way you can see it as is just x to the 4th times x to the negative 1/2. And then add, it's still subtracting, but that's another way that you can read that. Where's my eraser? So I don't need it. But yeah. X to the 4th minus 1/2. Cool. 2 times 4 is 8. 8 minus 1 is going to be 7. So this is just 8x to the 7 over 2. Now how can we convert this back? Because we still have this 2. And I believe you can find a way to fix this. Well, this is just going to be the square root, because we still have the 1/2 here. The 1/2 still exists. Square root of x to the 7th power. Now what? Now recall, 7 divided by 2, well, that's just going to be 3.5. So that means we can take 3 pairs of x's. X to the 3rd power, because we cut them in half, we can take 3 out, because this would be x to the 6th power. We're cutting them in half. So x cubed times the square root of x. Cool. Easy, right? Well, we're not done yet. We need to find the domain and range. So recall in our original function that x was in the denominator. We cannot have x be equal to 0. Can it be negative? Well, no, it can't be. Because if we have x in the denominator being negative, we would have a negative square root. And there are no real solutions to that. So, our domain, x must be greater than 0. And the same goes for our y. Our range, must also only be positive. Because this, we cannot have negative numbers here, so this is positive numbers only. And this is the square root. Anything negative we put here would only be positive. Voila. All right, 6th question. 8 power of x squared minus x is equal to 64. Let's do it. So 64, we can recognize that just by looking at it. That is 8 squared. Cool, and now we have same basis. This isn't even an exponential problem anymore. This is just x squared minus x is equal to 2. And then we can just take that out, bring it over, minus 2, x squared minus x minus 2 equals 0. This is just a quadratic equation. So, now what? We can just split this up. What multiplies to negative 2 as to negative 1? Well, that's just negative 2 and 1. So we can just do x minus 2, x plus 1. So we have our x's equal 1 and negative 2. And we are done. Voila. Cool. Question number 7. 7 to the power of 4x minus 3 is equal to 2x. All right, now we've got a big ruckus going on over here. So what I'm gonna do, and what worked for me, is that I'm going to actually just apply this 4 and this 3 to the 7, but we still keep x in the exponent. So 7 to the 4th power, that is 2,401. And then we have minus 3. That means we're dividing, divided by 343. All that to the xth power is equal to 2x. If you haven't noticed already, we're going to need a calculator. So we can't just plug this into a logarithm and then get it out. There's an x right here. If there was no x, this would be easy, but no. We need a way to get the x's down to the floor so we can start doing math with them. And how we do this is that we apply a log to both sides. Get a log in there, get a log in there. Because when we have a logarithm and there's a power inside of it, we can take that power down front. So I'm just going to do ln, natural log, of 2,401 over 343 times x is equal to x ln 2. That is great. So I think we can expand this a little bit further. Maybe we'll find another clue on how to solve this easier. We can expand this out when division in logs, we can change it into subtraction. Subtraction of log. So we can get x ln 2,000, whoop, that's a 4, 2,401 minus ln 343. All right. So our next step, I don't like all these x's, but I think if I divide both sides by x, I will cancel this one out and this one out. Of course, we'll be left with on here, but that is less x's to work with. And when we only have one x, then we can really start finding just for that one. So I'm just going to divide the whole thing out by x, which makes this cancel, this cancel, this cancel, this cancel. But there's still one x here. What do we do? So this new function, running out of space here, is just going to be ln of 2,401 minus ln 343 over x is equal to ln 2. All right, cool. Now we have this in a way that we can really solve it. Now I'm going to subtract ln, whoop, I'm running out of ink here, 2,401 from both sides. Ln 2,401. And then we are just left with this. Negative ln 343 over x. So I like our x in the top. So what I'm going to do, I'm just going to reciprocate. I'm just going to rewrite this reciprocated, which is just negative x over ln 343 equals 1 over natural log of 2 minus natural log of 2,401. Okay, cool. And now we're almost done. Multiply by ln 343. That way we can cancel this, cancel that, as well as actually multiply by negative ln 343. That way we also cancel out the negative. Makes sense? My Mac is dying. My audio recorder is dying. So, from the top here, we get ln of 343. Now, that is all equal to x. You're gonna have to put that into a calculator. God knows I'm not. Well, negative ln 343 over ln 2 minus ln 2401. And that is going to result in 0.8233. How about that? I'm recording. I told you. All right. Question 8. 2 to the power of x is equal to 4 to the power of x minus 2. So I see a lot of 2's, and I know 4 is a power of 2. So I'm going to rewrite this as a power of 2, and then we will see what we can do. Just 2 power of 2x. I don't see it yet. Maybe if I get this 2x over here as well, maybe we can make something happen. Minus 2 to the x. So 0 is equal to 2 power of 2x minus 2 to the x minus 2. Is there anything we can do here? I think it is worth noting that when we write 2 to the power of x, remember the parentheses, we write the powers within each other, we can see this also as 2 to the power of x squared. Now do you see it? A number squared minus a number to a power, you could say just to the power of 1, minus just a number on its own. Perhaps if I made a substitution, this would be easier to see. We are going to let y be equal to 2 to the power of x. So now watch this. We will have 0 equals y squared minus y minus 2. Now do you see? This is a quadratic term. And now we can solve like anyone would, a quadratic. Now, y squared minus y minus 2. What multiplies to negative 2 and adds to negative 1? Well, we actually already solved this equation. Our answers are going to be negative 2 plus 1. Y minus 2, y plus 1. Which means our solution is just y is equal to negative 1 and 2. But wait, we are not done. We made this substitution. We have to put our 2x back into the equation. 2 to the power of x equals negative 1 and 2. And now we will check. 2, negative 1, well, that is just 1/2. And 2, the power of 2, is equal... Oh, wait, I'm doing this wrong. I'm doing this whole thing wrong. Crazy? Ay, ay, ay. We had our solutions. -1 and 2 now equal to 2x. Equal to x. So, 2 to the power of x is equal to -1. Do we have a solution? You might think it is 0, but it is not. When we have any number raised to any number, unless this number is negative, the solution will never be negative. So there is no solution here. Cross it out. And 2 to the power of x is equal to 2? Well, come on. X is equal to 1. Only solution. Cool. Now, the reason I'm not skipping over this time is because our next question is very, very, very similar. Question 9, 4 to the x equals 2 to the x minus 2. We already know this is 2 to the 2x. And these are just the same terms again. So what I'm going to do, subtract 2 to the 2x. And our new equation is going to be a quadratic again. -2 to the x squared. I'm just skipping steps here. Plus 2x minus 2. Now I'm going to do my substitution again. We're going to let y equal 2 to the x. So our new equation is going to be -y squared plus y minus 2. Similar, but still very different. We just have a minus symbol over here. So now what? What can we do? So we can solve this in a normal way. Let's see, because remember, when we have a term over here, we have to multiply it by the end term before we start thinking about what multiplies and adds to each other. So, negative times -2, positive 2. What multiplies to positive 2 and adds to 1? 2 is a prime number. Its only factors are 2 and 1. Can we arrange those in any way to get only 1? I don't think so. So I think we're going to need the quadratic formula. So let's break the quadratic formula down and just do it step by step. Let's find the determinant first. Now, if you don't know what the determinant is, it is the point in the quadratic formula. It's this, square root of b squared minus 4ac. The determinant is really just this, but we nest it in this because this tells us if there are any real solutions to our problem. Because if this value is negative, square root of a negative, we get a complex problem, a complex solution. So let's plug in our numbers into this. So b, a, b, c, that is just going to be 1. I'm going to skip steps. 1 squared is just 1. Minus 4, what is our a term? A is going to be -1 times c, -2. This right here, the negative, is going to cancel and make this positive. So 1 plus 4 times -2. Now that is just going to be 1 minus 8, which gives us -7. So does our problem have real solutions? No. There are no real solutions to this problem. Now, we could mess around and find the complex ones, but I mean, I don't actually like using the quadratic formula, so we're not going to. But yeah, no real solutions. That is our solution.